So our goal for today's lesson is just to do these properties of exponents, but this time around we're going to have variable expressions to go ahead and simplify. So with regard to example 2, what I need to tell you about that is that I'm also going to lean on the properties that I taught you in P1. Remember, you had simple properties like the associative properties of multiplication and addition, commutative properties of multiplication and addition. So it's nice because this skill kind of ties those two lessons together. So when I look at 3A, I'm like, wow, that's a mess. So I'm going to organize it a little bit. My first step is just going to be to more or less use that associative property of multiplication to rearrange that multiplication. So see this -3 and 4? I'm going to put those together in their own groupings. And I can, because multiplication is associative. Notice there's no plus or minuses in the parentheses either, so I'm just straight rearranging the multiplication. I'm also going to put the a's together. So I have a to the first and a to the first. And again, you see that I'm already in the habit of, if there's no exponent, I still write one. That's just a reminder to me that I don't have to do anything with that. It's not a negative exponent. And then I would put the b's together. So I have b to the 4th times b to the -3rd. This is also not necessarily a step you have to show. It's a step that I think a lot of you would probably do in your head, but because I'm teaching you something, I'm going to go ahead and show it. So now I'm going to go ahead and simplify each of these groupings. So I got -3 times 4, that's -12. A times a is a squared. And then b to the 4th times b to the -3rd. Sure, you could use your upstairs, downstairs, or negative exponent rule if you wanted to, but remember that we can just add 4 and -3 together. So the sum of 4 and -3 is just 1. So that's that right there. Done. So this usually begs the question, how do we know we're done? Well, what you're going to see is that any unique letter that occurred in the problem only occurs in my answer one time. So what I mean by that is, for instance, I saw multiple occurrences of the letter A in my original problem, but I only see the letter A in my answer one time. Same thing with the B's. I have multiple B's in the original problem, but I only have a B one time in my answer. That's most commonly how you know you're done. Yes?
This might be like a dumb question, but why wouldn't there be like an exponent of -3 and 4? Since wouldn't they just be like 5 and 1?
So let me see if you're looking at that grouping right there.
No, the -3 times 4, why wouldn't there be like -3 to the first times 4?
Oh, I see where you're at. I was looking at the wrong one. So like right here and right here?
Yeah.
Yeah, you could put those there.
Okay.
That's not wrong. It's good habit. So you could go like this. Why I didn't write the exponents there? Remember, these properties of exponents only apply when we have like bases. So it was important for me to do it here because I had a times a, and then here because I had the b times b. So that's kind of why I was putting those there. Good question. I like it. Any questions on part A? Woo, it was really fun. Let's do it again. All right, so part B. Notice that there's no plus or minus signs in that set of parentheses there, which that's my cue. I am allowed to distribute that exponent to everything you see in that set of parentheses. So again, we could say, because we're about to apply our property of exponents here, I have 2 to the first, x to the first, and y squared, which means I need to distribute that 3 to every single exponent in the problem. So I'm going to do 2 to the 1 times 3 power, which is 2 to the 3rd. And then I'm going to do 1 times 3 for my power of x. 1 times 3 is 3. And then I'm going to do 2 times 3, which is 6. And then the last thing you want to do, this 2 to the 3rd, you don't really want to leave that as a final answer. 2 to the 3rd is just 8. So we usually evaluate any, thing that can be simplified in the problem. And that's my answer. remember, little self-check right now. You don't write it down if you don't understand it. Everything that's on that smartboard should go in your notes. So if you don't know, like, why is that an 8? Or how did you know to get x to the third? Those are the questions you want to ask. You don't write it down if you do not understand it. That is like a binding agreement. Well, good. All right, on to part C. Okay, so order of operations is something I always kind of keep in the back of my mind. You saw that when I was going over your homework assignment. So I look in the parentheses first, and I see if there's anything I could simplify in there. Negative 4a squared, there's nothing I can simplify there. So I do parentheses, then I do exponents in PEMDAS. So what I see going on right here is I have all of this, negative 4a squared right here, raised to the power of 0. Fun fact, our 0 exponent rule says anything raised to the power of 0 is just 1. So this whole grouping right here, the whole thing is raised to the power of 0. So that whole grouping right there, negative 4a squared, all of that raised to the 0th power is 1. And that happens because of those parentheses there. If those parentheses aren't there, we're looking at something quite different. So that whole quantity just turned into a 1. But the 3a, I mean, going back to it, those have exponents. If you're ever in doubt, you can write them. They're not raised to the 0th power. So the 3a, or the 3 to the first and the a to the first, come down. You could put a dot between them if you want to. You don't have to. It's implied. So if we do 3 times a times 1, that's just 3a. Okie doke. Last one in that row. So I have 5x to the third over y, and then that's squared, right? So notice there's no plus or minus signs in our parentheses, which means we are allowed to distribute that exponent in there. So, you know, I'm going to distribute that 2 to every exponent I see in the problem. So it'll be 5 raised to the 1 times 2. Shaylin, you can always tell me to move. I have a habit of standing there. So 5 to the 1 times 2 is 5 squared. And then 3 times 2 is 6. And then 1 times 2 is 2. So what I get is 25 x to the 6th over y squared. Bless you. Do you have a cold? Is it allergies? Do what we did to Josh yesterday.
What did you do, Josh?
We just grilled him when he had the sniffles. I thought that's what we did here. No.
What did we do?
You were the one that told me for the
Double standards.
See how it is. Any questions on those? All right, so the next grouping, I believe, takes it up a notch a little bit. So I kind of wanted to go through those with you, because this is where I start to throw in some of the negative exponents. So just, again, just taking it up one notch into example 3 here, and starting to like layer those properties a little more. All right. First one's not really bad. That's just x to the negative first. So the bad guy in that problem, the bad guy in that problem is that negative exponent there. So I would go ahead and just punish him by moving him to the basement. So x to the first moves to the basement, and then you do need a placeholder on the top. So that's just 1 over x. Notice I put the x to the first, but again, you don't have to write that exponent. It's just a tool. It's also not wrong if you leave it there. But again, reinforcing the idea that it's only the things that have the negative exponents that move. So if I put my 1s there, 1 to the first power has a positive exponent. 3 to the first power has a positive exponent. The bad guy in this problem is x to the negative second. So what's going to happen there is the 1 and the 3 get to stay put, because they have positive exponents. They're fine. I get this weird, like, in this class for whatever reason, it's like people think the 3 and the x to the negative second are like married. We cannot break them up. They are to be together until all of eternity, whatever. But in actuality, it's all just multiplication. And we have those properties from our first couple of days together that allow us to break those things apart and reorganize them. It's just multiplication. So sometimes my students, just to remind themselves that it's all just multiplication, they'll put dots in there too. Not that you have to, but you can. That looks messy. All right, so with that, the bad guy in this problem is actually x to the negative second. So I'm going to move it. It just moves to the opposite spot in the fraction. So because it was negative and on the bottom, to make that 2 positive, I bump it to the top. And then you could just write this as x squared over 3, or just leave it like that. All right, part C. Okay, so this guy here, notice I would love to use the associative property, but the issue is I can't multiply because I have this exponent of 3 in there. So if I want to get rid of that exponent of 3, I actually have to distribute that 3 into those parentheses there. Notice there's no plus or minus. So what I'm going to have is negative 5 to the 1 times 3 power, that's 3. And then I have z raised to the 1 times 3 power, that's 3. And then I do have the z squared that I can bring down. Notice I only put parentheses around that negative 5, and that's because it was negative. If it's positive, we would not need really any of these parentheses in this line here at all. So I have to protect those negative values, or else my calculator will give me the wrong answer, and I will give me the wrong answer because it means something different. So negative 5 to the 3rd power, that's negative 5 times negative 5 times negative 5. That's negative 125. And then I can use the power of a product property to just add 3 and 2 together. And I can simplify that, so that'll be negative 125 z to the 5th. That's my final answer. Alrighty, my very smart period 1 college algebra class. I got one more. Again, no plus or minus signs in those parentheses means I can distribute that exponent in. So I'm going to go ahead and do that. I have 3 squared, x to the 8th, x to the 4th on the bottom, and y to the 4th there. And I'm going to start simplifying this. I have 3 squared, that's just 9. And then I'm like, uh-oh, look at that. That is something I have to deal with. So I have x to the 4th and x to the 8th. And if you remember from yesterday, I said it's like they do battle. It's like they're football players on a line of scrimmage. You have 8 x's on the top, and if you had to, you could actually draw it out. This is long. I'm going to do it. You don't have to write it down if you don't want to. But we have 8 x's on the top. 1, 2, 3, 4, 5, 6, 7, 8. Over 4 x's on the bottom, right? 1, 2, 3, 4. Well, this guy takes out this guy, this guy takes out this guy, this guy takes out this guy, this guy takes out this guy. You have x to the 4th left on top. X to the 4th is left on top there. The shortcut we had, if you're wondering, is just to subtract those exponents. So we could have just done x to the 8 minus 4 and gotten x to the 4th. So when you have like bases, you're just allowed to subtract your exponents. And that's how we get that x to the 4th right there. Y to the 4th didn't have any friends, so it just stays the same. Good with that? All right, now you get to try a little bit. I'm going to stop our video here, and then I'll have these independent practice answers up for you for in Google Classroom, or I'll just show them to you here in a couple minutes.